The engine in your car is a furnace. It burns fuel. This creates power. But it also creates heat. This heat is a constant, relentless force. It is a normal part of the machine's life. But when that heat is not controlled, it becomes a danger. Too much heat is a quiet enemy. It waits for a moment of weakness. It can warp metal. It can melt vital components. Your engine can seize, leaving you stranded. A car that overheats is a car in distress. It is a warning sign you cannot afford to ignore. This is not about a minor problem. The causes are often simple. A small leak, a blocked passage, a part that costs very little to replace. These are the seeds of disaster. An internal combustion engine is a controlled explosion. Thousands of times per minute, a mixture of fuel and air ignites inside the cylinders. This process generates incredible heat. Just how much? A small four-cylinder car at highway speed can generate between 20,000 and 100,000 watts of waste heat. To put that into perspective, a powerful home space heater, 1,500 watts. Your car's engine is producing the heat of dozens of these heaters, all at once, in a very small, enclosed space. That is a massive thermal load that must be managed. This heat cannot be allowed to build up, or metal temperatures rise to dangerous levels. Aluminum cylinder heads can warp, pistons can expand and seize, oil can break down, losing protection. At idle, the engine might produce 5 to 20,000 watts. Climb a steep hill or tow a trailer, and that number can skyrocket. This is the ultimate test. About 1/3 of fuel energy moves the car, another third goes out the exhaust, and the final third is absorbed by the engine block. That last third is the cooling system's burden. 100,000 watts can heat a small house in winter. Your cooling system must shed that continuously. The heat is always there, waiting. The cooling system's lifeblood is the coolant, antifreeze, water. Circulates through the engine. It absorbs the immense heat and carries it away. The fluid is only part of the equation. The speed at which it moves is critically important. This is called the flow rate. The water pump drives this circulation. At idle, the pump might move 5 to 15 liters per minute, enough to remove heat even when stationary. As RPM rises, flow rises. On the highway, 30 to 60 liters per minute or more. Think about that. A bucket of fluid through narrow passages every 10 seconds. A sluggish flow is like a single drop on a hot pan. It boils away, doing almost nothing. A strong stream cools quickly. Your engine is the same. Slow flow cannot carry heat away fast enough. Coolant boils. Steam pockets form. Steam is a terrible conductor, making things worse. Warped heads. Catastrophic costs. Heavy load demands. Max flow. Any weakness, worn impeller, clogged hose, blocked radiator, reveals itself. Low flow is a silent killer. It allows heat to build, undetected, until the damage is already done. Between the hot engine and the cool radiator stands a small, vital component, the thermostat, a simple mechanical valve. Its job is to control flow, deciding when coolant can travel to the radiator to be cooled. Cold engine needs to reach operating temperature quickly. During this time, the thermostat remains closed, circulating only within the block. At about 85 to 95 degrees Celsius, 185 to 203 Fahrenheit, the magic happens. Wax expands. The pin opens the valve. The gate opens. Hot coolant flows to the radiator. Cool fluid returns. The thermostat cycles, regulating temperature with precision. The danger lies in failure. Stuck closed is most dangerous. Coolant never reaches the radiator. Temperature shoots into the red with alarming speed. Stuck open is less immediate, but harmful. The engine never warms fully. Heater blows cold. Fuel economy worsens. Wear increases. Stuck open or stuck closed either disrupts the balance. The gatekeeper must perform its vigil perfectly. The radiator is your car's heat exchanger, a network of tiny tubes and fins. Hot coolant flows through, Air draws the heat away. Over time, these narrow passages can become blocked. Old coolant breaks down. Rust and scale form inside the engine and pump. Gritty sludge circulating. The sludge seeks places to settle. The tiny radiator tubes are perfect. As debris builds, it restricts flow. A slow choke. At first, you may not notice. Light-duty driving still copes, but reserve capacity is eroding, mile by mile. Then comes a challenge, a hot traffic jam, a long hill, a small trailer. Heat surges. The compromised system cannot keep up. Hoses can degrade from the inside out. Flaps peel and restrict flow. Soft hoses can collapse under suction, pinching off supply. A hose can look fine outside, but rot within. Check the coolant. Its color and clarity tell the system's story. A clogged system runs on borrowed time. Reduced flow means chronic, low-level overheating. Wear accelerates. By the time the gauge spikes, damage may already have begun.
Your car will speak to you before it fails. You just have to know how to listen. The most obvious sign is the temperature gauge. Does it read higher than it used to? Creep up in stop and go, then drop on the highway? This fluctuation often points to a weak radiator fan or a partially clogged radiator. A healthy system stays stable. Any deviation is a warning. Listen to your heater. If air is lukewarm or cool, especially when the gauge reads hot, that's a major red flag. Coolant may not be circulating. Possible causes: failing water pump, stuck thermostat, blockage in the heater core. If coolant can't reach the heater, flow is compromised elsewhere too. Check the overflow reservoir. Bright translucent color is good. Muddy brown, sludge, or an oily film suggests contamination, possibly internal corrosion or a leaking head gasket. Steam, vapor, or a colorful puddle are obvious. Soft and mushy or hard and brittle hoses either means replace. A wet water pump weep hole. Take action. Ignoring these symptoms is a gamble. The car is telling you it is sick. Act before the sickness becomes fatal. At speed, air is forced through the radiator, carrying heat away. But in traffic, there is no natural airflow. This is where the radiator fan becomes essential, the guardian that protects your engine while stationary. Modern cars use electric fans controlled by a temperature sensor and a relay. The relay turns the fan on. You can often hear it whirring to life. The other type is mechanical with a fan clutch. Slow when cool, then it locks up as things heat, pulling more air. For an electric fan, let the car idle. Switch on AC. This usually forces the fan. If it doesn't spin, you have a problem. Bad motor, blown fuse, faulty relay, or bad sensor. For a clutch fan, with engine off and cool, try spinning it by hand. It should have resistance. If it freewheels, the clutch is likely bad. Classic signature, perfect on the open highway, but in traffic or a drive-through, the needle climbs. That's a failed radiator fan. It is the engine's only source of breath when it cannot make its own wind. You do not have to be a victim of overheating. Prevention is simple: vigilance and routine maintenance. The easiest check: coolant level. Do it monthly and only when cold. The level should sit between min and max. If it's low, you have a leak. Find and fix it. Topping off is not a solution. It's a temporary patch. This 2-minute check can save you from disaster. Coolant doesn't last forever. Anti-corrosion additives break down. The fluid can become acidic, corroding internals, creating sludge that causes blockages. Follow your manufacturer's schedule. Most modern cars, 5 years or about 100,000 miles. Older cars, maybe every 2. Always use the specified coolant type. Include cooling system inspection at every oil change. When cool, hoses should be firm, not rock hard. Look for cracks, bulges, soft spots, dried residue at joints and seams. Be proactive. A thermostat is cheap but critical. Replace it with hoses, or around 60,000 miles. If your water pump is timing belt driven, replace it with the belt. Prevention is not expensive. A bottle of coolant, a few hoses, a thermostat. Small investments. The price of peace of mind. The cost of keeping the unseen enemy at bay.
When the needle climbs into the red, the time for prevention is over. This is the final stand. Your first move: reduce the engine's load, turn off the air conditioning. The compressor adds work and heat. Then do the counterintuitive thing. Turn the heater on full blast. The heater core is a secondary radiator, pulling heat into the cabin. It will be uncomfortable, but it might save your engine. Find a safe place to pull over. Do it now. Do not try to make it to the next town or to your house. Every second does damage. Pull over, put the car in park, shut off the engine. The silence will be deafening. Open the hood to let heat escape, carefully. Everything is extremely hot. Do not open the radiator or reservoir cap. The system is under immense pressure. Opening the cap can unleash superheated coolant violently. It can cause severe burns. You must wait. Patience is your greatest tool now. The engine needs 15 to 30 minutes to cool. Watch the gauge. It may stay high for a while. When cool to the touch, check the overflow tank. If it's empty, that's a big clue. Add coolant if you have it, but remember, it vanished for a reason. A leak will bring the heat back. If heat subsides briefly, you may limp a short distance to a shop. Watch the gauge like a hawk. If it climbs again, stop immediately. The best decision is to call for a tow. A small fee beats a destroyed engine. The battle against heat is won with vigilance and knowing when to stop. Safety must be your final word.